Oscillators, very important topic, which converts DC to AC signal, or which converts DC or noise signal to AC output signal, or it is nothing but without giving any AC input signal, which will give the AC output signal. That is oscillator. There are two types of oscillators. One is LC oscillator, second is RC oscillators. LC oscillators and RC oscillators, these two are sinusoidal oscillators which will generate sine signal. LC oscillators and RC oscillators. Today we will discuss about LC oscillators. The first one is COLPITS oscillator. COLPITS oscillator. This is the CE configuration. Transistor NPN transistor in CE configuration. This is emitter, and this is base, and this is collector. So at emitter we have RE and capacitance CE. Similarly, we have biasing resistors R1, R2, biasing resistors RC, collector resistance, and here the CC coupling capacitance or output capacitance. Here we will collect the output. This is CE configuration. Here we are not giving any AC input signal. Here we have to use one LC network as feedback network. So that is nothing but we have to connect capacitances like this. This is C1, this is C2, and in parallel we have to connect one inductance. This is L. C1, C2, L. This is nothing but LC network acting as the feedback network, nothing but from output to input. This is output. In between output and input we have to use one feedback network, that is LC network. This is CC, coupling capacitance at input side. So this is coupling capacitance at input side. From output to input we have LC network. This is feedback network. This feedback network provides 180 degrees and this CE provides 180 degrees. Total is 360 degrees phase shift. To get conditions for oscillations, 360 degrees phase shift, and second is A beta is equal to 1. This is another condition. These two are the conditions for oscillations. Very important. So here, without giving any AC input signal, whenever we give supply VCC, this feedback network, LC network, will activate and will generate some signal that will be connected to the base of the transistor, that will be amplified, and we will get the output as sinusoidal signal like this. Sinusoidal signal like this. This is the output of the COLPITS oscillator. The frequency is F is equal to 1 by 2 pi square root of L into C equivalent. 1 by 2 pi square root of L into C equivalent. C equivalent is nothing but 1 by C1 plus 1 by C2. If you simplify this, C equivalent is 1 C1 C2 by C1 plus C2. This is about COLPITS oscillator. Similarly, if you go with another oscillator called as a CLAPP oscillator. CLAPP oscillator is nothing but small modification in the COLPITS oscillator. Nothing but one capacitance is in series with the inductance, that is called C3. We are going to, in the COLPITS oscillator, in series with L, if you connect one capacitance C3, then it is nothing but CLAPP oscillator. Then the feedback network consisting of C1, C2, C3 and L. If you connect these capacitance, it is acting as a CLAPP oscillator. Then the frequency of oscillation is same formula, and 1 by C equivalent is equal to 1 by C1 plus 1 by C2 plus 1 by C3. That's it. So next capacitance we have to get, that is 1 by C1 plus 1 by C2 plus 1 by C3. That is C1, C2, C3 by C1 plus C2 plus C3 in place of C equivalent. That is CLAPP oscillator. Similarly, we'll go with another oscillator called as HARTELY oscillator. Third oscillator, small modification, same CE configuration here. Same CE configuration. In place of L capacitance, we have to use inductance L1 and similarly L2, and in place of L we can use C, that is C. So in place of two capacitances we can use L1, L2. In place of inductance we can use C. Then it is nothing but HARTELY oscillator. HARTELY oscillator, very important. HARTELY oscillator. HARTELY oscillator is nothing but we have two inductances in parallel with one capacitance. Same CE configuration provides 180 degrees, and this feedback network provides 180 degrees. Total phase shift is 360 degrees. Then the frequency formula is 1 by 2 pi square root of L equivalent into C. Square root of L equivalent into C. Then L equivalent is equal to, we have two inductances L1 plus L2 plus 2M. L1 plus L2 plus 2M. Here we have two inductances, and first inductance Z1 is equal to J omega L1 plus M, and Z2 is equal to J omega L2 plus M. This is a mutual inductance. Because of that, we'll get L1 plus L2 plus 2M. 2M. So this is 1 by 2 plus square root of L1 plus L2 plus 2M into C. This is the Hartley oscillator. In this, we are going to discuss about three oscillators, all LC oscillators in a single video, that is COLPITS, CLAPP and Hartley oscillator in very easy way in the descriptive manner. In the next video, we will discuss about complete derivation for all these three oscillators.